This is a rather neat little thing. It's a fridge deodorizer, but it's also designed for things like cupboards. The only place they recommend not using it is in a freezer. It's designed for small spaces, but the freezer is too low a temperature because this thing does contain a lithium cell. And the idea is that you can stick it in a fridge and you press the button in the back and a blue light lights. And I don't know if you'll hear this, so I'll hold it up to the microphone. Can you hear it? It's making a sort of high-pitched buzzing, whining noise. And there's a smell of ozone at the end here. It's got a little emitter for ozone. And it will run for 30 minutes, and then it will go into a standby mode. And this LED will start flashing, and then it will just operate for 5 minutes every hour until the battery is literally flat. And then you can plug it into a micro USB, the red LED lights, and it goes on charge, and it's ready to use again. It came very nicely packaged, although I have to say putting tape on the cardboard box wasn't such a great thing. And the box is clearly designed for it. It's a good fit. And the foam is cut out here to prevent the on-off button being accidentally pressed. Comes with a little USB charging lead and instructions that are actually in English. And it describes it as, the steriliser can kill all sorts of bacteria, remove odour for fresh indoor air according to the sterilisation principle of zone. It is safe and does not produce any secondary pollution. Sterilisation rate reached more than 99%. It's controlled by a microprocessor, that'll be the wee 8-pin chip, and sterilises surrounding space at regular time. Gives the statistics, says it contains a 500 mAh battery, ozone output 2 milligrams an hour, and that's very hard to actually measure effectively. Applicable area less than 2 cubic meters, so it is just designed for small spaces like cupboards. So the listing for this basically gives those same details, and it was £13.20, came from a seller called Power Offer Store and was shipped directly from China, and describes it as USB mini ozone generator, fruit vegetable cleaning refrigerator deodorant machine. The fruit and vegetable cleaning is usually a sort of text that's included with the sort of the water-based ozonators. So let's open it and take a look inside. First thing I'm going to do, I can see there's a little dimple here. I think there might be a screw in the middle, but I could be wrong. Let's peel this off and see if there's a screw. No, there's not. It's just a moulding sprue point. Okay. So the next thing I'm going to do is spudger it. Where's my spudger? Where's my spudger? There's my spudger. Isosamo to the rescue. Oh, quite tight. Oh, that is quite tight. Let's try around this side. Ah, it's not too bad, not too bad. Wasn't too bad. Oh, there we go, there we go. Let's not stab this into a lithium cell if possible. Oh, I've only broken one, that's all right. Ooh. It's got little connectors, that's nice. Oh, let me zoom down in this. Let me zoom down in this so you can see what's inside. We have the lithium cell. Oh, the lithium cell's not even screwed in. You can actually just lift it out. We've got the little control PCB, which we'll take a closer look at. There is an electronic module, and there is the ozone generator itself. Let me show you a close-up of the ozone generator itself. I shall bring it up here. I shall focus on that, and we'll get a close-up. And it is literally, it's a stainless steel, presumably stainless steel, since that's the most resilient, metal spike behind another piece of presumably stainless steel with a hole in it, and that creates a high potential difference between the two from this power supply. Well, this creates the potential difference, and that will probably create a corona discharge. Now the question is, can I show you that corona discharge? Can I make that visible? Just give me a moment, I'm going to try and do this. Okay, this is the best I could do here. See that little dot moving around the middle of your screen? That is the corona discharge. It's a tiny glow. It's barely visible to the human eye. So let's cut back to the chase and take a look at the circuit board. So I shall turn this off. Well, I guess the only way to turn it off right now is to unplug the battery, because I just bridge the contacts to get that going, and we'll take the other bits out here and we'll take a closer look at them. So I'll unplug the high voltage module as well. I should really have noted what these were, but that's all right. I can watch the video to see where they went. So here's the little power supply module. Let's whip it out. I don't think we're going to see much in this one because it will be potted in resin. They usually do. It's really common with these. It will almost certainly be a little what they call a Royer oscillator type thing, based on a couple of transistors pushing and pulling a transformer. And the output of that is going along these, well, they've got one fairly thick silicon lead, the other will be reference to ground, maybe, I'm not really sure. And this just lifts out the little corona discharge generator, and it really is just that little spike behind the metal ring, same as the sharp plasma cluster, how it produces its little trace of ozone. Right, let's get the circuit board out and take a look at that. It's going to have an 8-pin microcontroller on it. I just know it is. A transistor to switch that on, and then the charging circuitry. It's going to be very, very textbook. It's going to be what we'd expect. But let's take it out and look at that. Okay, well, I'm seeing the little MOSFET that switches the output, seeing the little charge. Right, tell you what, I shall give you a close-up at this and then we can reverse engineer it. Here's the circuit board, the side that was out of sight underneath when it was mounted, and here's the top side, the connectors. So I've flipped the top side over, that's why the text is all back to front, just so that, say for instance, where you can see the red LED correlates to here. And that means that this connector relates to these pins and that one relates to these pins. It just makes it that little bit easier for following through. However, I'm regretting the use of the word following through there, the phrase, but not to worry. There are tracks underneath this microcontroller. The microcontroller, which has a software version, it's a blank chip, rather predictably, V1 version 1 A842. Not sure what that relates to because it doesn't relate to the model number. However, things worthy of note, the USB charge port goes via this Schottky diode to the charge chip, which is set with a 2K resistor. It's set to charge the lithium cell here, protected lithium cell, with about 500 milliamps. The microcontroller controls the whole show and switches the boost circuit, this little ioniser module, via this MOSFET, which is a very odd choice of MOSFET. I thought they might have used something like an A2SHB, but they've used another very standard MOSFET, the 8205A dual MOSFET, commonly used in battery protection chips. Interesting choice. The little module that's being powered actually says 5 volts, less than or equal to 45 milliamps, 1 to 2 milligrams an hour. And I thought this might have been made by the same company and just designed to slot into their case. But it looks like this power supply and this emitter are probably both from the same company. And it's got little mounting holes here that you can actually fasten it into something. It's an interesting little arrangement. It is just a simple point. I'll draw that later, point behind a circle with what I think is DC being applied to it. I think this is a voltage multiplier as well as a high frequency step-up circuit. The lithium battery that I mentioned, this is 500 milliamp power, and it does have a protection circuit on it. Let's take a look at the schematic. The schematic. Let's tame this down just a little bit. Is that going to tame it down too much? No, it's not that bad. So the power comes in from the USB port, and it goes, it's quite odd, it uses the LED, the red LED, as a jumper as well, which I thought they'd have had that red connection over on this side, but they don't, the red LED positive. But it goes to the red LED and it goes to that Schottky diode, which is designed to just drop 0.2 volts. That's purely, I'm guessing, for polarity protection. They could have used a standard silicon diode and it would have taken a bit of the dissipation off this if they'd done that, because it would have been dropping about 0.6 or more volts across that. But it goes to this charge chip, which is an LP28056. I think the 056 is the clue, because if you think TP4056, it's a very standard type of chip, but I'm guessing they're just using common numbers. And that has not really much to it. It's got the current going, it's got the control out for the LED, it can control another LED as well, but it doesn't. And it's got this 2K resistor going to the negative rail, which sets the current that it's going to charge with. The other bit of circuitry over here is a simple voltage divider, 10k and 62k, and it's going straight to the chip just to tell it when it's charging. And this is odd. When you plug this in to charge, it turns the output off. I thought it might have been useful just leaving it on, so you could actually just leave it on a charger all the time, but they don't seem to want that for some reason. It charges the protected lithium cell, and then there's a good few decoupling capacitors in here. There's this small 100 nano-ish type one, I presume. I didn't measure it because it's in circuit. A electrolytic at 220 microfarad, 10 volt. And then over next to the booster, the high voltage module circuitry, there's another decoupling capacitor. Then we have the microcontroller. And what makes me think it's very similar to a PIC12F629 or a PIC12F series is that pin 4, which would normally be the memory clear, or master clear, should I say, in the microchip PIC instruction manual, it warns you should always use the resistor to pull that up to positive if it's not used. So they've used a 47k resistor. The button has a debounce capacitor across it. There is a 2k resistor and an LED, a blue LED to show it's active. And then it's using a 1k resistor to limit current to the gate of the MOSFET. It's optional. A lot of people just drive them directly, but I tend to prefer a resistor. But it's got the 10k resistor, the classic 10k resistor pulling that down. That is actually 2 MOSFETs. And that powers the high voltage module. And the high voltage module simply, it boosts that voltage up, and then it's got a very sharp spike just behind a metal ring. And if you were to look at that, ultimately, it's creating that high voltage. And I have tested this. I'm pretty sure it's DC. But if that's a sort of cross section of it, it's not like an ioniser where you're going to get lots of like negative ions coming out the front. Because it's basically got these the opposite polarity next to it, the charge all goes there. And what that happens is you get quite a strong corona discharge at the tip. I mean, it's not super mega strong, it's just barely visible. But it also, because of the flow of electrons, it tends to create a little electron wind through as well. And you can hear that when you hold this up to your ear. When it's powered, you can get a slight sort of ioniser effect of the wind blowing against your ear from it. And that kind of moves the air through the unit at very low level in a sort of without any moving parts. In a way, it's like the ionic breeze that was sold by Sharper Image, but on a much, much smaller scale. Things worthy of note. I did test the current. The run current when the module's powered is 30 milliamps. The module, it does say, is 5 volt, but it draws about 30 milliamps when it's powered at the 4 volts of a freshly charged battery. As the battery goes down, the current falls, and at 3.6 volts, I measured 25 milliamps, so the output will gradually diminish as the battery drops. When it's off, the quiescent current, when you turn it off, there's a slight pause, and then the current just drops down. It puts it to sleep, and it only draws 1 microamp while it's asleep, just actually under 1 microamp, 0.8 microamps, which would be 800 nanoamps. When it's running, it draws that 30 milliamps, but when it switches into auto after half an hour, I thought it would go to sleep, but it doesn't quite. It's blinking that LED and it's timing, but the current drops down to 2 milliamps. Now, in a way, that's a shame, because I calculated that based on the fact that it initially starts with running it continuously for about half an hour at 30 milliamps, that's about 15 milliamp hour to start off with. And then it runs every 5 minutes, which means that over the course of a day, it's going to run 24 times for that 5 minutes. Hold on, let me just work that out. 24 times the 5 minutes equals 120. So it's going to run for 2 hours at 30 milliamp hour. So that's going to be about 60 milliamp hour just with its daily run time. So it starts off the day with the initial burst, say about 15 milliamp hour, because it runs the half hour, plus that other 60 milliamp hour, that's 75 milliamp hour. But because of that sneaky little 2 milliamp standby current that was not needed, they could have just put it to sleep and used internal timer to wake it up. But because of that, that's consuming about another 50 milliamp hour per day, which actually is pretty much doubles the current consumption per day, which is a bit odd. So we're now getting about 60 milliamp hour a day plus, so that's about 110 milliamp hour a day, which means that off your 500 milliamp hour battery, you're going to get about 4 days or something like that from it. Initially, beforehand, I didn't realise it drew that little sneaky extra standby current of about 50 milliampere hour a day. And it would have given a whole week beforehand. But maybe that will change. As the current goes down, the voltage boost circuit will gradually reduce in current draw and the output will reduce. So I'm not sure how long it would last. But I don't think it's going to last a full week. But it's still not too bad. It means that you can just stick it in a cupboard or your fridge. The way I was using it, I just initially just stuck it in and left it in for a day. And then that sort of deodorized the thing. I don't know if you'd really need to leave it in all the time unless there was a strong odour issue. There was with mine. It was cheese, out-of-date cheese, that I was still planning on eating. It was super stinky. I ate some, thank you. It was great. I'll probably have the shits later on as a result of that. But there we go. It's an interesting circuit. It's kind of textbooky. The design is okay. Some oddities, they've really just ticked every box. But the whole image I get of this unit is that it's actually pretty good quality, that they've designed it well, because it's actually a nice construction. I love the fact the battery just sits into a little channel. It's not glued in. It's got a bit of foam in it, but that's just enough to give it friction into that channel. And I like the fact everything's on with connectors, and it uses this little standard module. So it's quite neat. I have to say, that is quite a smart little unit. Well worth getting and taking to bits. It's actually a lot better than I was expecting, which probably justifies its sort of higher than cheapy crap type price. It is a decent module. But there we go. Interesting and well worth taking to bits. Bonus extra footage. People often ask me, what do I do to the products once I've taken them all to bits and reverse engineered them? Well, the answer is that I usually put them back together again. Sometimes, if it's not worth putting back together again, I'll strip all the good bits out and scrap the rest, or I'll modify them and just sort of hack them a little bit just to suit what I want. However, in this case, I have to say this one, I decided I'd put it back together, but this case has a little sort of indented lip all the way around it, plus clips that go down the side, and it is the hardest case I've ever had to close. It was easy enough opening up, you saw how easy it spudgered open, but actually getting it closed again required significant pressure along each edge, working all the way around, and when you got two in, the third one was really hard to get together. So that actually took quite a bit of time to put back together again. But it is back together, and it is doing its little ozone thing. So yeah, interesting little thing. Quite a complex little case, but it seems a well-manufactured product.